All right, so welcome back. So in this video, we are as you have seen the title and the probably thumbnail, we are going to learn about autoencoders, mainly the introduction to autoencoders. So the last video, we have officially ended the like for now we have ended the GAN series. There are a lot of papers coming up. Like if you go to papers with code and just look it up, there are many more papers that have come. I'll probably cover them in the future videos in this image generative section only. I'm going to cover all of these maybe new papers on both GAN and different other models. Right. So in this video, as I've told in the title, we are going to learn about autoencoders. You might have heard about them, maybe not. Let's first look at what the idea is. You might, after listening to the idea and probably listening to the model, you might say, why do we actually need it? Well, I'll answer that question too. And at the end of this video, I'm going to instill a question inside you, or a statement inside you in which you could figure out something, maybe just like an assignment or something, just a thinking test, right? That like I believe that should be the main test, right? Like that's how test should be. You should be forced to actually think. So yeah, so let's start. Let's get started. So what is autoencoders? So the main goal of autoencoders is to actually compress an image. So you might say, some might say that the main goal of autoencoder is actually compress the image. For example, you have an image like this, and let's say you're training a huge model, right? So you're probably training a something like stable diffusion, right? We actually use this idea in stable diffusion. How can we actually like take a very high quality image and convert it into a very low dimensional feature vector, or yeah, low dimensional feature vector that can hold all of this content and all of the meaning inside those like little matrix, like comparatively little sized matrix. So that is the idea. And again, this is actually used to also do image generation to generate new images. That is possible. But after listening to this idea, that i'll I'll let's just go through it. I'll let's continue what the idea is of autoencoder. So given an image of, let's say, x by y by n, or 3, right? 3 is the number of channels, right? So given an image like that, to probably do something like that. uh, I'm very bad at drawing. So given an image like that, how can we actually convert into a very small dimension or very small feature vector through which we could actually like represent the whole image? That is a basic idea. So you you might have learned about you have learned about CNN, right? So if you have stayed with me, maybe in the CNN section, or maybe CNN section, maybe I've when I have uploaded the videos. If you are with me, you would have known about CNN, or even if you are any like deep learning, even if you took any deep learning course, you must be familiar with the concept CNN. So what we'll be doing is we'll be performing many CNNs to actually downsample this image. Right, we'll after performing CNNs, of course, we are going to reduce the dimensionality of the image, and we can update these kernels. I'm actually going to draw like diagrammatically, right? We're going to have like CNNs, right? And then we will just, you know what? I'll just draw this very much clearly. So as you can see, right? So you take in a huge image and slowly convert into a very smaller one, and then suddenly you'll get a very smaller output. So you would have just performed this CNN on this image, and successfully you have converted this image and represented this image into a very small dimension. And to make sure that this image holds the value of this, we're going to add another block. So this is actually called the encoder block. Encoder block. Encoder means encoding this image. So we'll have this image, right? So we'll be encoding this image into a very smaller dimension. So that is the encoder block, to actually encode it, to represent it in a uh, very efficient format. So that is the job of an encoder. And after that, we're going to build a decoder in which we'll slowly use convolutional transpose, CD, convolutional to transpose or any upsampling layers. And we'll slowly increase that image to actually be equal to this shape. So these both are going to be the same shape, and essentially we want the model. So I'll tell you what we're going to do here. So as we have, this is going to be the encoder, right? And this is going to be the decoder. So what we are going to do is we are going to take this small dimension output, right? And then we're going to perform multiple CNN transpose layers to actually upsample this image into the actual image. So what we're going to do is, just to make sure that this is the actual representation of this image, what we're going to do is we are going to rebuild this image. Essentially, when we are building the loss function, so we are not going to do any architectural changes to actually make pressurize the model to actually regenerate the image. So we are going to make the changes in the loss function. What we are going to do is in the loss function, we are just going to use an MSC loss on this and this, right? So what we are going to do is we're going to take in the input image I, and then we're going to take in the output image y, let's say, and we're going to use calculate a y MSC between I and y, and we just want to make sure that the loss is as low as possible, right? So we want to make sure that the model actually predicts the same image. So right, so model predicts the same image exactly like this. It can actually regenerate that image. So given an image, firstly use an encoder layer to actually downsample this image, right? We want the model to actually specify it or represent it in a very lower dimension, and and then I have to have a decoder block next, through which we could actually upsample this image very slowly, and then we could have many layers, like many CNN layers, and we will have this final output, which will be the actual image, right? And then we can use a loss function which specifies the MSC, which is nothing but the MSC loss or mean squared error between the actual image and the output image, and we're going to propagate this loss based on like back propagation, right? We're going to calculate the back propagation and update all of these neurons. We're going to update all of these values, right? Weights. So that is the idea of autoencoder. So the idea essentially is, so what is the need, right? So the need is, finally we could, like, this is the main thing, the smallest dimension. So the basic idea is we are successful to actually convert this huge image into a very smaller representation. And in fact, when you are training actually image generation models, when I'm actually building anything, for example, when I'm training stable diffusion, right? When I was training stable diffusion, I've actually used this variational autoencoders or autoencoders to actually encode this each image. We used to just encode each image into a very small dimension, and we could do the training process, right? We could, before training, we could just create like a lot of these blocks rather than inputting a lot of big images. We could just have these small blocks, and in fact, it could further downsample it if you want to further decrease the complexity, but still better, the higher the features, the better features can be tracked, because while in the inference time, right, we want the we are normally there will be a lot of diversity of images. So just to make sure that all the features are tracked, we might want to increase the number of values in there. Anyway, so this is the idea of autoencoders. Now after listening to this pretty naive model, you might have come out to this idea, how does this model, you might just say, Joel, how does this model actually is related to image generation? How can we do new image generation to this model? Because if we think about it, right, for example, let's say this is the image. So for example, I'm going to come back. If you think about image generation, what image generation is? For example, in this context, so we'll take in this model, this value, this small vector, right? We'll take in this small vector, the decoder vector, and we just pass this to this decoder and get an image, right? We just get an image, right? When we pass in this uh, latent vector or feature representations, we'll pass that to a decoder and get an image, right? So that is the idea of image generation. at least in this context. But the thing is, no matter how many times we send this representation, we're going to get the same image in the inference time, right? In the inference time, when we're actually using this model, no matter how many times we send the same representation, no matter how many times we send it, we are going to get the same image. We're going to get the same image again and again and again. So that is going to be a problem, right? So that is definitely going to be a problem because, yeah, because we can't generate new images. Image generation is all about generating new images, and we could actually do that. So that is one thing. I'm going to tell you in the next video how we can actually generate new images to this using an idea of like mean and standard deviation. I'm going to cover that in the next video. So that is one idea. And then I think this is encoders, auto encoders, and so essentially the idea is actually taken this image, encode it into a very small representation, and again decode it into a this output. So this is the research paper. Feel free to go through this and check this out. And again, and one thing is this image is going to be blurry, pretty blurry, because like, of course it is going to be blurry because we have like very smaller dimension here. All right, so this is the idea. We'll have a original input, we'll pass that to an encoder, and we'll get a very smaller representation. And then we could pass that to the decoder and get the image reconstructed input. So we'll essentially reconstruct the input. And there's many methods here also in this paper. I'll definitely recommend you to read that. I'll probably read that for the next video. I'll probably read this paper again to explain it for you in the next video. So yeah, just I mean, that's it. I think that's it. Yeah, so that's it for this image. The idea is again encoder to actually encode this into a very small feature vector and decode to actually get that final image, right? And then we could actually use this to perform many things, right? We could actually use this to actually perform many things. And while training, for example, models related with images, rather than passing this image, you could just pass in this feature representation and we of course train the model off first, right? And we could just use these feature representations to actually like learn, right? So that is the idea. And then yeah, and the question I want to leave you with is, how can we generate new images? How can we make the model to generate new images? So that is a question that we'll be solving in the next video. So yeah, thank you for watching. I think this is a very short introduction, and in the next videos I think we'll go through like some of the applications, and I'll try to cover something. So thank you for watching. I'll see you in the next video.